Welcome to this explainer from Forge College. I'm so glad you're tuning in. So, in our previous lesson, Hands-on Configuration and Resource Scripting, we built some absolutely pristine configuration scripts for our Solana deployments, right? I mean, they look perfect on our screens. But today we're diving into troubleshooting network configuration issues. We're figuring out exactly what to do when those shiny configs meet the harsh reality of deployment and, well, immediately crash. Because let's be honest with ourselves, configurations almost never work perfectly on the first try out of the gate. That's just a fact of life and development. So we're going to tackle these network hiccups head on.
Here is our diagnostic game plan for today. We'll start with that inevitable uh-oh moment, move right into gathering evidence, probe the connection to isolate the issue, apply a single fix, document our findings in a debug report, and then wrap the whole thing up.
All right, part one, the uh-oh moment. Basically what actually happens when your configs crash.
Now, hitting failures when you're deploying to a network like DevNet or MainNet, totally normal part of the development cycle. It seriously doesn't mean you're a bad dev. It just means you're dealing with a really complex distributed system. Now, on the left side here, we've got a working network. Smooth HTTP 200 OKs, lightning fast response times. It's exactly what we want to see. But on the right, the failing network. HTTP 5XX errors, curl failed messages, agonizingly long response times, and those pesky DNS errors. To really wrap our heads around this, we're going to intentionally trigger a simulated network failure today. We'll deploy a client config with a super tight 200 millisecond timeout and a misrouted endpoint. That is going to instantly turn those happy HTTP 200s into a panic-inducing wall of red timeout errors.
Moving on to part two, gathering evidence. The main takeaway here, don't panic, just look at the logs.
So when that giant wall of red errors hits, your very first instinct is probably going to be to wildly mash the keyboard and start randomly changing settings. We have all been there. But you gotta resist that urge. Instead, you need to act like a detective arriving at a crime scene. We use simple, trusty command line tools as our magnifying glass before we go in and contaminate the evidence. Tools like PSIUX, LSOF, and ULimit check our system descriptors to see if our local test validator is simply gasping for air because it ran out of file descriptors. From there, network reachability tools like ping, traceroute, and dig will quickly tell us if we're dealing with a larger network outage or a routing issue rather than just a local bug.
Before we get any further, let's clarify our primary suspect here, the RPC endpoint. Basically, this is the specific URL where your application connects and actually talks to the blockchain network. You can think of an RPC endpoint exactly like a phone number. If you have even a single typo in that URL, your app can ring that number all day long, but absolutely nobody is going to answer. It's a complete dead end.
Which brings us to part three, probing the connection and isolating the actual issue.
All right, so we've gathered our initial system logs, and now we need to zero in on the exact suspect. To do this, we're going to run a custom Node.js script, let's just call it probe.js, to repeatedly ping the network and record exactly when, and more importantly, why the connection fails. And the results here are incredibly revealing. Look at this. With a tiny timeout of 200 milliseconds and a wrong URL, the result is an immediate timeout or an HTTP 5XX error. Setting a 200 millisecond timeout is literally like dialing a phone number and aggressively hanging up the receiver before the other person can even say hello. Contrast that with a much more reasonable 5,000 millisecond timeout, pointing to the correct DevNet URL, which gives us that beautiful HTTP 200 success. I mean, the contrast is night and day.
Okay, part four, the single fix. Doing things one change at a time.
We have our evidence from the logs, and we've isolated the behavior with our probe. But listen, this is where ultimate discipline is required. You have to resist the urge to make 50 changes at once. No cowboy coding here, folks. If you go in and change the URL, the timeout, the retry policy, and your local firewall all at the exact same time and it suddenly works, you'll have absolutely no idea what actually fixed the problem. You've just totally confused the diagnosis. Instead, follow this core engineering workflow. Step 1, collect initial logs. Step 2, formulate a solid hypothesis based on that evidence. Step 3, and honestly, this is the magic step, apply one reversible change. In our case, that means using a tool like JQ to update our config to point to a reachable DevNet RPC and bumping up the timeout to 5,000 milliseconds. And always keep a backup of the original config so you can easily revert. Finally, step 4, verify the fix and roll back if things actually get worse. This methodical approach is exactly what we teach in all our learning programs here.
Now, what does verify actually mean in this context? It doesn't mean it works once and we just pack up and go to lunch. To quantitatively verify that our single fix actually solved the root cause, we need hard data. For our simulated test, we want to see at least a 70% success rate across a 30-attempt request loop. If we hit that 70% benchmark of HTTP 200s, we know with absolute confidence that our config adjustment successfully stabilized the connection.
Section 5. The Debug Report. Time to document the case.
Okay, we're stable. High fives all around. But wait, we aren't quite done yet. Once the system is stable again, our final engineering task is documentation. Because let's face it, human memory is faulty. We want to ensure that neither we nor our teammates make this exact same configuration mistake twice. A perfect debug report is not a novel, okay? It's a precise, actionable record. It needs context and initial evidence, those crucial first log snippets we talked about. It needs your hypothesis. It requires the exact config diff, literally the before and after of your code adjustments. It needs that verification output showing the 70% success rate. And finally, recommended next steps. Preserving this kind of institutional knowledge is a professional engineering practice that truly separates the amateurs from the pros.
And speaking of recommended next steps, I want to introduce a fantastic concept you could include right there in your report, the circuit breaker. Basically, this is a brilliant software design pattern that automatically stops making requests when errors start to spike, which prevents a localized issue from causing a massive systemic failure. If you noticed your timeouts were causing cascading failures earlier, recommending a circuit breaker on client retries is just a stellar way to gracefully handle future network hiccups. Finally, Part 6. Wrap up and final checks.
We've covered a ton of ground today, right? We literally turned a chaotic wall of errors into a perfectly documented and resolved engineering case. So here is your golden checklist. 1. Always save initial logs before tweaking anything. 2. Collect system and network signals to isolate the issue. 3. Apply a single reversible configuration change. 4. Verify recovery with a quantitative benchmark, like our 70% success rate. And 5. Produce a clear, comprehensive debug report. You now understand how a tiny little config typo or a slightly aggressive timeout can completely masquerade as a catastrophic network failure, and much more importantly, you know exactly how to methodically resolve it without breaking a sweat.
Which brings us to our final provocative question. Are you ready to deploy your configurations safely into the wild? You now have the tools, the specific workflow, and the resilient mindset to tackle network hiccups like an absolute pro. As we prepare to move into our next module covering foundations of deployment strategies, I highly recommend you head over to forge.college to explore more of our Web3 resources. Make sure your foundational knowledge is rock solid so you can deploy with total confidence. This explainer was brought to you by Forge College. Thanks so much for joining me, and happy debugging!